Hi everyone, welcome back to another video. In today's lesson, we will talk through three questions, specifically question 3, 4 and 13 from the 2024 Primary 6 WA1 paper from Methodist Girls School. As per usual, if you want to give this paper a try, it is linked in the description down below. And as per usual as well, I do not own any of these test papers. These are readily available on the internet. So let's move on to our first question. Our first question, question 3, is asking about a car that is battery operated. Before we begin, we need to figure out what this question is really asking. So this question is really asking about the energy conversions as stated in the question from its beginning to its output. So from its input to output. So the input itself is the battery because this car is battery operated. The only options that you have is either electrical energy or chemical potential energy. As some of you might know, batteries come in different shapes and different forms as well, but they also contain different chemicals. For example, you have alkaline batteries in the form of your AA and AAA batteries. We also have lithium-ion batteries, which is common in laptops and handphones as well. And last but not least, in recent times, there's even silicon carbon batteries, which has rose to prominence in 2025 in newer cell phones. So the answer here is either 3 or 4 because you have to start off with chemical potential energy that is present in the battery itself. Then and only then is that chemical potential energy is converted to electrical energy, which powers the car altogether. From electrical energy, you can tell from the diagram that the car produces sounds via sirens, it produces light flashes as well, and last but not least, it also produces kinetic energy in the form of movement when the car moves from the right hand side of the picture to the left hand side. So all in all, the output here is kinetic, light and sound energy, which is option number 4. Okay, so just to recap everything that we've talked about so far, we start off with the chemical potential energy that is present in the battery. In this case, it possibly could be alkaline batteries because you are probably using AA or AAA batteries. And then from there, it is converted to electrical energy that powers the car. From electrical energy, it is converted to light energy in the form of the flash, converted to sound energy in the form of the sirens, and converted to movement of the car in the form of kinetic energy. So the correct option here is option number 4. Next, we move on to question number 4 itself. In this question, a student named John wanted to investigate the factor affecting the rate of photosynthesis using the following setup. And there you see the setup itself, and below the setup is the results that he got from his experiment. Keep in mind that for the graph, you can tell that as the number of bubbles increase, variable x also increases to a certain point. So the question then continues to ask, which is most likely the variable x that John was testing? I really like this question because it is a tricky question for those who are not paying attention, myself included. For those of us who are not paying attention, we'll take one quick look at the diagram and think that variable x is distance. But you will see in a short while why that is not the right answer. So what is this question really asking? This question is asking about the rate of photosynthesis. Before we continue, let's have a short recap on photosynthesis. Okay, so for photosynthesis to occur, you need to have carbon dioxide, you need to have one plant, which is present in the form of the pondweed here, and you also need to have light. For rate of photosynthesis, the more light you have, the faster the rate of photosynthesis, and eventually the more bubbles you have, because oxygen is the product of photosynthesis. So by this logic, you need to find something that increases the rate of photosynthesis. If you were to take a look at the options available, option 2 and 3 are immediately out. Why? Because amount of sugar and amount of oxygen is not necessary for photosynthesis. Again, for photosynthesis to occur, you need to have carbon dioxide, a plant, and you need to have a source of light. Option number 4 is also not the right answer. The main reason why is because if you were to increase the distance between the light and the beaker with the pondweed, that would mean that the plant will get lesser light. If the plant gets lesser light, the rate of photosynthesis will decrease. If the rate of photosynthesis decreases, the number of oxygen bubbles also decreases. So that would mean that option number 4 is not true, especially for the graph above. So the most likely answer here is amount of light, which is true because as mentioned earlier, if you were to increase the amount of light, the rate of photosynthesis would also increase. Why? Because the plant will get more light. As the rate of photosynthesis increases, the number of bubbles also increases to a certain extent, and this rings true to the graph you see here. So for question number 4, the answer is option number 1. Okay. So before we get to that, here is a short recap of what I talked about. As x increases, variable x increases, the number of bubbles also increases. This will not be true if x was distance. Why? If distance increases, lesser light reaches the plant. If lesser light reaches the plant, the rate of photosynthesis would definitely slow down. Slower rate of photosynthesis would mean lesser bubbles. And that would mean the graph is not true. So let's take a look at the options available again. Oxygen and sugar, which is option number 2 and 3, are definitely out because these are not needed for photosynthesis. So the only option left is amount of light. As light increases, more light will reach the plant. The rate of photosynthesis would also increase. Will get faster, and a faster rate of photosynthesis would mean more bubbles are generated, which is true for the graph you see here. Therefore, the correct answer here is option number 1. Next, we move on to question number 13. A student named Timothy here is carrying out an experiment with different rubber straps. The rubber straps is attached to a catapult which he used to launch a stone. As you can see, the table here listed shows the distance the stone traveled for each rubber strap. So for 13a, it is asking which rubber strap W, X or Y has the most elastic potential energy. By the name elastic potential energy, you can imply or you can guess that it means which one is the most elastic, which one can stretch the most. If we were to take a look at the table, rubber strap W definitely has the most elastic potential. Because if you were to think about it, the longer we can stretch the rubber strap, the further the stone can travel. And based on the table you see here, the stone that travels the most was with the rubber strap W. Therefore, rubber strap W has the most elastic potential energy that can be converted to the most amount of kinetic energy to shoot the stone the furthest distance when compared to the other two rubber straps. So here is everything I talked about. By the name elastic potential, you can guess that it refers to how elastic something is. So the higher the elastic potential, the further the band can stretch. The further the band can stretch, the further the stone will travel because you will get the most kinetic energy. So by that logic, rubber strap W is your answer here, and it has the highest elastic potential. So here is the model answer. Keep in mind the bolded words are the key points you need to have in your answer to get the full 1 mark. W is the answer. Using rubber strap W, the distance traveled by the stone is furthest as rubber strap W has the most elastic potential energy to be converted to the most kinetic energy in the stone. Next, we move on to question, or at least part B of question 13. So for each rubber strap, explain why Timothy has to pull the rubber strap to the same distance for it to be a fair test. Let's have a short recap. For every science experiment, there needs to be only one variable. So a variable is something that you change. In this experiment, Timothy has decided that the variable will be the rubber strap. That will mean everything else has to remain the same. And this includes the amount of pulling done on the rubber straps. Why? Because if you were to think about it, the shorter you pull the rubber strap, the shorter the distance will travel for the stone. The longer you pull the rubber strap, the further the stone will travel. We already have one variable here, which is the type of rubber strap, so everything else needs to stay the same. So here's the explanation written on the screen itself. If Timothy pulled the rubber strap different distances, it will affect the distance the stone will travel. A shorter pull will cause the stone to travel a shorter distance. A longer pull will cause the stone to travel a longer distance. Thus, Timothy needs to pull the same distance for all three rubber straps to ensure it is a fair test. One thing to keep in mind for all future science experiments that you do, you have to make sure that everything else needs to stay the same as well. So for Timothy to make this an even more accurate test, he needs to ensure that the angle of the catapult itself is also the same for all three rubber straps. He also needs to use the same stone for all three rubber straps, and as mentioned earlier, Timothy actually needs to pull the strap the same distance for all three rubber straps as well. So here is the model answer. The distance traveled by the stone will only be affected by the type of rubber strap, but not the distance he pulled. And with that, we've come to the end of the video. I hope that my explanation helps you understand the concepts that were tested in the questions listed here. I wish you all the best for your examination, and I shall see you in the next video.